Okay, so first thing, we want to verify the alternate form of the Pythagorean identity. So we know sine squared plus cosine squared equals 1. We want to verify that 1 plus cotangent squared is cosecant squared. So when you are given a statement that's already in equation form and you're asked to verify, you start with half the equation and you write it down. So 1 plus cotangent squared, I've done that for us. And then you do algebra magic on this half until it looks like the other half. So our goal is to do some algebra magic on 1 plus cotangent squared to make it look like cosecant. So, what do we know about cosecant? How do we define cosecant? Let's look at our goal. What is cosecant? 1 over what? 1 over sine, yeah, S. 1 over sine. Cosecant's 1 over sine. I don't see any sines in here. How am I going to get a cosecant? So I need to rewrite the trig function that's there in terms of sine. Because I need a cosecant. Cosecant depends on sine. So what is the definition of cotangent? 1 over tan. Does that give us a sine? No. What's the other definition for cotangent? We know it's 1 over tan, but that doesn't give us a sine. We need a sine in our function. What's the other definition for cotan? That's tangent. Cotan is cosine divided by sine. It's the flip, yeah. We know that cotangent is cos over sine. That looks promising to me. I've now got a sine squared in the denominator. Cosecant squared has a sine squared in the denominator. That's great. But I have some stuff floating around I don't want there. Starting with a cosine. So my goal is, let's see if I can write cosine in terms of sine so I don't have cosines floating around. Cosecant is only 1 in sine. I shouldn't have cos. We have a relationship between sine and cosine at the top of that page. That's the Pythagorean identity we started with, which is sine squared plus cos squared equals 1. This was originally how we got from one to the other. We learned that way back in January. I want to make a replacement for cosine in my equation. So I need to get this guy by itself. Need to isolate the cos squared. So we're going to do some algebra. Any suggestions on how I get rid of the sine over here? How do I undo addition? Subtract. Yeah, let's subtract sine squared from both sides. On this side, those guys cancel. And I'm left with cos squared. On the other side, I have 1 minus sin squared. So cos squared is 1 minus sin squared. So I know that those two things are the same, which must mean these two things are the same. And I'm going to make that substitution. If cos and 1 minus sine are the same value, the same number, I can replace one with the other. Make a replacement. So we rewrite. I have a 1, he comes down. I have a plus, he comes down. I have a fraction. with sine squared on the bottom that comes down. The only change is the numerator. Instead of cos squared, I'm replacing it with something equal to cos squared. 1 minus sine squared theta. It looks gross, but as a mathematician, I know that my goal is cosecant squared, which only has sines in it. I have only sines floating around. That's a good start. I've gotten rid of all the other trig functions. Now I just need to make it pretty. Now it's just simplification, yeah? So my instinct is let's split that numerator into two separate fractions. 1 plus, and then I'm going to separate the numerator. I'm going to have a fraction for the 1 minus a fraction for the sine squared. And I know that's okay because if I started on this line and I worked backwards, the denominators match, I would just squish the numerators together, which would take me back to where I started. That's allowed. That's okay. And I see some stuff. Keep your hands to yourself, please. Math is not a contact sport. I see some stuff that's going to get pretty. Anything divided by itself is what? It's 1. This thing becomes 1. Looks scary. It's not actually scary. 1 over sine. What is 1 over sine? Cosecant, which is what we were looking for. So this is cosecant squared because it's 1 over sine squared. Yeah. And I'm just going to rewrite that so it's less messy. I have a 1 plus a cosecant squared minus a 1. Ooh, closer. Much closer. Yeah, there are like terms there. There's a plus 1 and a minus 1. We should combine those numbers together because they are like terms. What is 1 minus 1? 0. Those 1s are going to cancel, which leaves me with cosecant squared, which is the goal way back at the beginning. Meaning I'm done. I'm done. Yeah. And if you wanted to be casual, you would put a happy face because you're done. If you wanted to feel sassy, you would write Q E D quod erat demonstratum, which literally means that which was to be proven. Makes you feel smart when you write that on the paper. But that is what mathematicians write when they're done proving something. I did not expect you to remember that, but now you've seen it. And if you take math again in college, you will probably see it again. Yeah. Felt a little scary, yeah? This is the worst case scenario. Yeah, that's the big scary problem. We're going to do the opposite end of the spectrum in a minute. Most problems will be somewhere in the middle in terms of difficulty. Yeah, this is kind of the biggest, scariest one we're going to do. The big important thing that we just did when we started is that we worked on one side of the equation to make it look like the other. Yeah, we didn't write out the whole equation, 1 plus cotangent equals cosecant. We just chose the 1 plus cotangent squared side. And the question is, how do I decide which one side to work on? And the answer is you always want to pick the more complex side. pick the side of the equation to start that has more stuff going on. The reason we're doing that is it's easier to simplify a complex expression and squish it down than it is to take something simple and expand it into something messy. I can clean up a mess. It's really hard to take the simple thing and make the original mess that it came from. So mathematically, it's easier to start with the expression that looks scary and reduce it down to the one that doesn't look scary. Yeah? Once you've done that, you're going to take everything you know about trig, which is at the top of the page in your toolbox, yeah, along with everything you know about algebra, factoring expressions, squaring binomials, adding fractions, grouping like terms, yeah? And the goal is to take the complex side and shrink it down to the second side, the simple side. Yeah. This probably looks a little intimidating to a lot of you. This is hard. You get faster at it with practice. There is no shortcut for this. For the first couple of these that you do, it is going to feel like trial and error. There isn't a wrong way to do it, but sometimes you're going to make a substitution that's not helpful. Yes?
Are we always going to have to substitute? Like, you know how to
Yeah, for trig functions, generally part of that simplification process is going to involve a trig substitution, which is why I started with the trig toolbox. Yeah, and once we've done that substitution, that's often where our other algebra skills come in. Yeah, that was a good question, Bonnie. So for your homework, while you're doing this in Delta Math, when we're practicing it Friday and Monday, don't be afraid to grab scratch paper and just try something. If it doesn't work, try something else. Yeah? You have a big toolbox of trig knowledge. You have a lot of algebra knowledge from Math 1 through Math 3. Try something. If it doesn't work, try something else. Yeah? If you get frustrated, put that problem aside, come back to it. But don't give up. Yeah? This just takes practice. You will get there. Okay, we're going to do one that's very similar to the one we just did. You guys are going to help me. Then we're going to do a couple that are a little bit different. Yeah? Some of you look like you're going to cry. It makes me sad. I promise it'll be okay. Why is it like this? There we go. That's the one I need. Okay. All right. So, next example says verify the alternative form of the Pythagorean identity 1 plus tan squared equals secant squared. I think we just did one of these. Means you guys should be able to tell me what I should be doing. Ooh, you're right. That was the second step. But notice this section's blank. Which side of the equation do I start with? First half, the complicated half. 1 plus tan squared. Take the complex side, squish it down. So 1 plus tan squared. And eventually, I want that right side to be this. So when I start substituting and simplifying, this is the goal that I keep in mind. What is secant? Secant's 1 over what? Cos. 1 over cos. So this time while I'm doing my substituting and my simplifying, I know I'm going to want a 1 over cos squared at some point. And so I'm probably going to try and rewrite this expression with a bunch of cosines. Yeah? So let's do Vani's suggestion first. Vani said let's do a substitution. What do we want to substitute here? Tan, what is tan? It is 1 over cotangent, but that doesn't give us a cosine. Sine over cos. Yeah. So this is going to be sine squared theta over cos squared theta. And that makes us happy. Just like the last problem, I've now got a cos squared in the denominator, which is going to get me my secant. I just have to get rid of the sign. Suggestions on how I do that? Ooh, very good. We use that Pythagorean identity. Sine squared plus, oops, there should be a theta there, plus cos squared equals 1. Yeah. Last time we were solving for cos. Now I'm solving for sine. I want to get sine by itself. Subtract. Very good. We're going to subtract that cosine from both sides, which is going to give us sine squared theta equals 1 minus cos squared theta. Yeah, I agree.
This for you?
One of those is for me.
This one.
Yes, these are mine. Thank you. Oh, wait, not all of them. Wait, only one of them. I only have Yaya. I don't have these two. I don't have an Elijah.
Okay.
And I don't think, if that's an Angie, I don't have an Angie.
Okay.
Yeah.
You got the other one?
Yeah, I gave her the other one. Yeah. Thank you. Okay. So we make the substitution. The thing that equals sine squared goes in for sine squared. 1 plus big ugly fraction with cos on the bottom. Numerator is now 1 minus cos. Better. I've only got cosines floating around. Happy? Suggestions on what we do next? Split it. Yeah, split the fraction up. 1 plus, and then 2 fractions. 1 over cos minus cos over cos. That becomes a 1. 1 over cos is secant, which makes this pretty. Yay. 1 plus secant squared minus 1. Combine the like terms. Plus 1 minus 1 becomes 0, which leaves us with secant squared theta. Happy face. QED. Success. Yay. That was a long one. They won't all be that long. Yeah? We're going to try another one, a little more straightforward. Same principles, a little less intimidating. So example 2, same wording, right? It says verify. Verify the identity tan theta cos theta equals sine theta. So which side of the equation do I start with? The tan cos or the sin? Tan cos, yeah. Start with the complex side. Tan theta times cos theta. And I want to turn that into a sine. My goal is this. So we're looking for substitutions or changes we can make that will get me there. Suggestions? Jennifer, suggestion? So remember, we're only modifying this side. So the goal is to get sine as an answer. I don't have sine up there. So what can I do to this? Ooh, definition of tan. And what is tangent equal to? Oh, I didn't mean to write that there, sorry. Sine over cos. Right? That's one of those fraction definitions. Tangent is sine over cos. Yes?
Then can't you just cross out the cosine and cosine?
You You can. Happy face. The joy with verifying identities, doing mathematical proofs, simplifying trig expressions is that sometimes they take one line. Sometimes they take 3 pages. You won't see anything quite that heinous here, but they can get really, really complex depending on what you're doing. So best case, it's a one-line thing, right? There's one substitution and then you reduce. Worst case, you're looking at those Pythagorean proofs we just did, where there's a couple lines, you have to do a substitution, you have to do a definition change, you have to do some reducing with fractions. Yeah? Those are kind of the 2 extremes for this class. I'm going to pop one more on the board, similar to example 2, a lot less complicated than the Pythagorean identity one. And I want you to try it in your small group. I'm going to give you about 5 minutes, and then we'll talk about example 3 together. Yeah, that's the last thing we're going to do today, example 3. So take about 5 minutes in your small group. Stop touching each other's stuff. Why is it always this table?
Because she's always right.
Well, he wrote on mine.
I didn't do anything.
I don't see any stray marks on yours. I see a circle on his.
I did.
Do I need to put you 2 in separate corners
As long as
with little dunce hats because you're acting like elementary school kids in a college classroom?
I mean, if I could take left suits.
You tell Mr. Joel.
Frowny face. Personal space and boundaries. Don't touch each other's paper. Don't touch each other's bodies. Don't touch each other's stuff. Yeah? Hands and legs in your own personal space. I should not have to say that to college students.
Mr. Joel,
Hmm.
here, how would I know which one that I could move?
Ooh, so remember, when we're verifying, we don't write the whole equation. We write that side of it, and then we think of things we can do to these to reduce it to 1. So if all I have is that there, cosine is as simple as it gets, right? Sine and cos were the original 2 we learned about.
Yes.
But these 2 have fraction identities. Cosecant is 1 over what?
Is it cosine? Or sine?
It's sine.
Okay.
Tangent is what over what?
Cosine over sine. Sine over cosine.
Sine
Oh
over
my God.
cos. So replace these guys with their fractions
Uh-huh.
and see what reduces.
Okay. Thank you.
Cross cancel everything that cancels.
So everything that's the same, like this.
And what are you left with?
Zero, one. Oh.
Um, we're missing a student.
Counselor.
What?
Where's counselor?
So counselor came to the door.
No, he went to go and talk to counselor.
Did he get a pass? I don't see a pass.
Oh.
Frowny face. Frowny face. Frowny face. It's a lot less funny. Frowny face. I mean, yes, this is a college class, but you are on a high school campus and some of you are minors. I still have to keep track of where you are. Got about a minute left. I know some tables have already solved it. Start thinking about how confident you are and whether you're willing to share. So my suggestion, and I think Nati's already figured it out, is two of these guys have fraction definitions, just like we did up here. Replace those guys with their fraction equivalents. What is cosecant equal to? 1 over what?
Sine.
1 over sine. Good. What's tangent equal to?
Sine over cos.
Yeah, I'd make those two substitutions and see what reduces. Hmm.
Very silly question.
Okay.
So he's asking.
It was just a joke, Mr. Jolly.
No judgment. There is no judgment in this class. Yeah.
It wasn't serious.
If your grade is like a college class, so then can we also just walk out like a college class?
So, if this were on a college campus, yes. If this were on Hartnell College's campus, absolutely. And I wouldn't check you down or even notice, because I don't take attendance in my college classes usually, except for the first day where I have to check how many people showed up for census. I don't check. But because we're on a high school campus, I have to follow high school attendance rules. Yeah. That's not a stupid question. You guys are in this really weird gray zone where part of you is being treated like a college student and part of you's not. Yeah. Okay, do I have a volunteer who's confident enough with their answer that they would be willing to share it with us on the board? Yes, come on. I think we're just writing with our finger today. One day I'll buy a stylus for the TV again, but not today. After you're done writing, you can do the writing first. It's hard to talk and write at the same time. That's why I get paid the big bucks. Okay, can everybody see? All right, can you walk us through what you did?
So I just wrote out the cosecant in the fraction form, and I just wrote out tangent. So then I just crossed out the cos and the sine and was left with 1.
Very good. Yeah. So this looked a lot like example 2 in that all I was doing was a definition, substituting in those fraction definitions of those functions. Yeah? Very good. Most of these problems are going to start very similar. You're looking at things that are defined as fractions and seeing if substituting in those definitions will reduce things. Yeah. So in this case, cosecant became 1 over sine. Tangent became sine over cos, because that's how we defined it. Yeah. So it didn't disappear. We replaced it with something equivalent, and then pieces of it canceled out. Yeah. No, that was a good question. Other questions? See a frowny face. Okay. Okay. So tomorrow we're going to finish those notes. There's some practice with simplifying, using some algebra skills like factoring and squaring. Try your delta math. You've got a little more knowledge to do that. Yeah? And come see me if you need help with something. Yeah? And check your grades. Please check your grades.